So now we are going to talk about another important contact force, that is normal force. Okay, see, so I have exam pad in my hand. Okay, I have this mobile phone. I kept the mobile phone on the exam pad. Wait a minute. I take the duster. I kept the duster on this exam pad. What is the state of the duster? Whether it is rest or in motion, it is at rest. Okay, it is not moving. It is not moving either towards left, towards right, upward, downward. It is at rest. Why does this duster is at rest? Don't you think there is gravitational force acting on this duster? See, same duster. Okay, same duster. If I remove this exam pad, if I release this duster, what happens? Duster falls on the ground. Gravitational force. What is the reason why does the duster falls on the ground? Due to gravitational force, right? So due to gravitational force, duster falls on the ground, but same duster when kept on the exam pad, it does not fall. What is the reason? Do you think there is no gravitational force right now acting on this duster? Doesn't exist? It exists. Gravitational force exists right now also. Contact, that force is called normal force. That normal force which is act opposite to the gravitational force, balancing this duster. So gravity, okay, acceleration due to gravity g, okay, there is a force on this gravitational force right now towards down. It is not going down because this pad exert the equivalent force, equal magnitude of the force on the duster in upward direction opposite to the gravitational force. That force is called what? Normal force. Okay, see, I explain with the help of a diagram. This is a exam pad. Okay, here we have a duster, right? So this duster is at rest because on this duster there are two forces are acting. This duster is pulled by the earth. The gravitational force act on any mass of the body is called weight, that is due to gravitational force, and another force is acting on the duster in upward direction. What is it? Normal force. So there are two forces are acting on this duster. I draw this way. This is the exam pad, this is the duster. So gravitational force acts downward direction, normal force acts upward direction. Okay, who exert the gravitational force? Who pull this duster down? Earth. Then opposite to gravitational force, another force act on this duster which is equal to the gravitational force but in direction, opposite in direction, upward direction. Who exert that force? The surface of the exam pad. So the force exerted by the exam pad on this duster perpendicular to the surfaces in contact. Okay, so surfaces in contact means, how do you understand? This is the surface, this is the surface of my hand, both are in contact. So perpendicular means this way, 90 degrees. Okay, perpendicular to the surfaces in contact. Okay, this is called a normal force. If you don't take horizontal one, if you take slant one, if the object kept this way, now normal force also acts in this case also, but gravitational force acts downward direction, but normal force not exactly opposite to the gravitational force. Normal force always perpendicular to the surfaces in contact. This is one body surface, this is other body surface. Two surfaces are here in contact. This is the surfaces which are in contact, perpendicular to the surfaces in contact. That means this direction. Perpendicular means this way. Normal force acts this way, perpendicular to the surfaces in contact. Okay, this is the surface. Okay, surface of this block or duster and exam pad are in contact this way, perpendicular to the surface. Normal force acts this way, but not always opposite to the gravitational force. It acts perpendicular to the surfaces in contact. For example, I am thinking like this. I kept my hand on the duster and I just lean to the wall. I am thinking like this. I kept my hand on the board. this way. See, I am exerting force on the duster and on this board. In which direction? Let's say this is a board. I exert the hand, I exert the force with my hand on this duster. In which direction? Perpendicularly. Surfaces in contact. This is the marker board. Okay, this is my hand, both are in contact. I am exerting force this way, and that board also exerting force on my hand in opposite direction. Whenever two bodies are in contact, both bodies are exert force one on each other. For example, if this is the block A, this is the block B, okay, two blocks are in contact, okay, then this, due to the contact, the surfaces are in contact, right? Whenever the surfaces are in contact, they exert force one on each other. This A exert force, block A exert force on the block B. In which direction? This is the surfaces which are in contact. Always normal force acts perpendicular to the surfaces in contact. This is surfaces in contact. Perpendicular means how do you take this way, right? So this is block A exert the normal force on block B in this direction. This is a normal force exerted by the block A on block B, okay, right? And this block B also exerts the normal force on the block A. In which direction? Perpendicular to the surface. The magnitude of these two forces are same. Normal force is same, okay. If you take two blocks, for three blocks, for example, this is one block, block A, this is other block, block B, and this is other block, block C. A, B, C, there are three blocks are in contact. Block A in contact with block B, direct contact. Block B is in direct contact with block C, right? But there is no direct contact between block A and B, A and C. So we can expect the normal force between A and B. A can exert normal force on B. B also can exert normal force on A. It is possible because these two surfaces are in contact, okay. So let's say A exert normal force on the B perpendicular to the surfaces in contact. Here the surfaces in contact, perpendicular means this way. B exert normal force on A perpendicular to the surfaces in contact. Let's say it is also N1, because if A exerts some force on the B, B also exerts same force on the A. Magnitude of the forces is equal. Exerted by each is equal. Now B in contact with the C, okay. Now B exerts normal force on the C perpendicular to the surface in contact, and C also exerts normal force on the B perpendicular to the surface in contact. So this is N2 and this is also N2, and here the normal force between A and B is N1. Here the normal force between B and C is N2. These two normal forces are not same, they are different, okay. But the normal force exerted by A and B, B on A is same. Normal force exerted by B on C, C on B is same, because they are mutually directly in contact. But the normal force between A and B, normal force between B and C is completely different, okay. So from this discussion, what do you understand? The basic thing you have to understand is, whenever two bodies are in contact, okay, normal force come into act, okay. See, this is the first body, this is the second body. When two bodies placed one on each other, first body, okay, this is the body which is first body, exert the normal force on the second body in which direction? Perpendicular to the surfaces in contact. And this body also exert the force on this body in which direction? Perpendicular to the surfaces in contact, right? Whenever two bodies are in contact, compulsory there is a normal force, okay. It acts perpendicular to the surfaces in contact. For example, I draw a V-shaped groove this way. Then I place one ball, spherical ball, sphere in this. Here this ball not in the contact. That means every point is not in the contact. Only certain point is in contact. So where can we expect the normal force? Here there is a contact. So here we can expect the normal force between two each other. Here also normal force we can expect. Where there is a contact between the two bodies, normal force come into act. Okay, both bodies perpendicularly exert the normal force perpendicular to the surfaces in contact. Okay, here this is the surface in contact, normal force exert perpendicular. Here it is a surface in contact, normal force exert perpendicular. Here it is a surface in contact, normal force perpendicular to surfaces in contact. Here also normal force perpendicular to surfaces in contact. Okay, whenever you place block X and block Y this way, now tell me what is the direction of the normal force. So this is the surfaces, these two surfaces in contact, this is the surface in contact, right? Here surface in contact perpendicular to the surface in contact. That means this X exert the normal force on the Y in upward direction, and this Y exert the normal force on the X in downward direction. You see these both are perpendicular to the surfaces in contact, and this normal force exerted by both is same. Okay, right. So the basic thing I hope you understand, because I explained many examples. Okay, as you are 8th class student, understanding the normal force, okay, is a little challenge, but I'm expecting with these examples you understand the normal force in a better way. So from this discussion, we can define the normal force in this way. So how do you define the normal force? The force that exerted by any solid surface perpendicular to the surfaces in contact, perpendicular to the surfaces in contact, is called a normal force. Okay, so another important point. Normal force, one on each other perpendicular to their surfaces in contact, right? So this is about normal force. Okay, see in the previous example, very first example, when I kept the duster this way, there is a gravitational force on this duster. The duster has to fall down. It has to fall down, right? But it is not happening. Okay, it doesn't happen. What is the reason? This exam pad exert the force on the duster perpendicular to the surfaces in contact, which is equal in magnitude to the gravitational force, and the direction is opposite. Gravitational force acts on this duster in downward direction, but this exam pad exerts the force on this duster in upward direction with equal magnitude of the gravitational force. That is why these two forces are balanced. These two forces are balanced. Due to the balancing of that two forces, this duster will be at rest. So what do you understand why the duster is being at rest? Because forces are balancing. That means net force acting on the duster is 0. Okay, so more about net force we discuss in coming video. Okay, so now we are going to talk about important one of the contact force, that is tension force. Okay, let us understand. This is the rigid support. With the help of this rigid support, let's say we have suspended one mass or one block or a stone or a bob with the help of this string. This is called a string, daram, string. Okay, so when we suspend this way, this is okay. On this, how many forces are acting? Let us understand. So actually, if we cut this thread, what happens? It falls on the ground because of gravitational force. But if we want to do that, it is at equilibrium state, because gravitational force as usually acting on this block in downward direction. When gravitational force acting on this block in downward direction, something force that has to balance this gravitational force in upward direction. Is it right? What is that force? That is called a tension force. Where does it exert? It exerts along the string away from the body. So this is called a tension force. So this tension force exerts along the string away from the body, always away from the body. That is called tension force. This tension force is balancing this gravitational force. That is why now this block is at equilibrium state. You see this. What is happening here? With the help of this rigid support, I have suspended one mass. Okay? If I release or if I cut this thread with the help of scissors, what happens? It falls on the ground due to gravitational force. But right now it is not falling because this is pulled by the gravitational force, and this is the force acting, gravitational force acting on this stone in downward direction, but that force is balanced by the tension force. So the tension force is acting along this string in which direction? Away from the body. So that tension force is balancing this gravitational force. I hope you understand. Okay. So the force which acts along the string is called tension force. The force which acts along the string is called tension force. So tension force is a contact force because this string and this mass both are in contact. Okay. It is a contact force. And what is the important thing we have to discuss regarding this tension force? It always acts away from the body. I explain one more example for better understanding. Let's say this is the table. Here one block is arranged this way. Here one block is arranged this way. Both blocks are connected with one string. And here we have a pulley. Now this thread is passing over the pulley, and that is connected to the one more block this way. Okay. So here where we can expect the tension forces. See, here this block is, on this block gravitational forces act downward direction. So here this tension force is balancing that gravitational force, right? Where there is a contact, this string is in contact with body, there compulsory exert gravitational force. Here pulley in contact with string. So here tension force is away from the pulley. Here also tension force away from the pulley. Here tension force is away from this block. Here tension force away from the block. Here tension force away from the block. Here my intention is you have to understand the direction of the tension force. This is the block. You see tension force acts away. This is the block. Tension force acts away on both directions. This is the pulley. Tension force away. This is the block. Tension force is away, not along the body, away from the body. So tension force always acts away from the body. It always acts away from the body. I hope you understand what is tension force. It's a contact force because string and the masses are in contact. Okay, string and masses, blocks, pulley, all these are in contact, right? So this is about the tension force. Okay, so till now we have discussed contact forces, non-contact forces, including examples in detail. Okay, in the next video we are going to talk about net force, free body diagrams, effects of net force, how to draw the free body diagrams, more exercises we will do. Okay, so thank you children. Please note down the definition of this tension force and refer these notes. Have a nice day.